Hello everyone, this is Pablo from the C# Academy, and in today's tutorial we're going to create a coffee journal with AngularJS in the front end and .NET C# Web API in the back end. It's a fully functioning CRUD application where you can add, delete and update data about your coffee records, and we'll also be handling validation with Angular and creating modals upon each operation. And we will be handling different screens as well, so the application will be fully responsive. This tutorial is part of the C# Academy, which is a resource tailored for absolute beginners, and it has a very clear roadmap with several projects for you to go from beginner to advanced in C#, ASP.NET MVC, Angular, and in the future React, Blazor, and .NET MAUI. And we also have a growing community on Discord where you can ask questions, talk about your journey, and get help with your projects. This tutorial is for beginners, but not absolute beginners. So you need to have created at least one C# Web API before and also have done at least one Angular project and know the basics of JavaScript. This is a practical tutorial, so that means that I'm not going to dive deep into each subject. I don't want you to get stuck in this project for months, but there are several links in the details below to the most important topics in this application. So of course, if you're feeling stuck or if you don't understand a subject, take a step back and dive into these links. It also has a fairly fast pace, but don't forget you can always slow the video down on YouTube to make things easier to understand. And it's also very helpful to take notes, especially in regards to each step that I'm taking, so that you can use it for your future projects. And if you hover over the code, both Angular and C# are fairly well documented, so you will be able to clarify many doubts about the code. It's something professionals do all the time. And of course, don't forget to use a debugger. It's a very powerful tool for developers. If you haven't used it yet, take a step back again and learn it from one of the links below. It's something that will take some time in the beginning, but then it will save you a lot of time and trouble in the future. And if ultimately you still don't understand a given concept, look it up on Google or Stack Overflow or any other communities. There's a huge community out there with excellent resources, so you can fix pretty much any problem by just looking it up. To make things a little bit easier for you when you're following this tutorial, you can access the code for each part of this app in different branches in my GitHub repository, so you can copy and paste the necessary code when needed. This application will have an Angular front end that will have a service that calls a web API through HTTP requests, and this web API is a C# web API that will communicate with an SQLite database using Dapper as an object relational mapper. So these will be two different projects. First, we're going to create the web API using Visual Studio, and then later the front end using Visual Studio Code. So let's go. So let's start by creating our API. In Visual Studio, let's click on New and choose the API project. Here we're going to choose to configure for HTTPS and use controllers, and also to enable OpenAPI, which is an interface that makes our life easy when testing our API. Click on Continue, and then let's choose where our project will live in our computer. Here I'm creating a new folder for that. And then you can choose a name which will be by default the same name as the solution. Click on Create, and a fully functioning API will be scaffolded for us. So here we have a solution with one project, the Coffee API. And this project has multiple folders and a few standalone files. The first folder is the Connected Services folder, which we won't be using in this application since it's a standalone application. It's not connected to any other services. Then we have the Dependencies folder, which shows us information about the frameworks that we are building this project on, and information about NuGet packages, which are libraries we can attach to our project. Then we have a controller with one endpoint, which provides random information about the weather. In the properties folder, we have the launch settings.json, which has information about how we are going to run the app. In the app settings.json, we're going to have configuration data, which will be really simple for this app. In this app, we're only going to use it to hold the connection string to our database. Then we have the Program.cs, which is the starting point of our app, and any service, dependency, or configuration that our application needs to run is going to be set up here. As a beginner, you don't need to have a deep understanding of the Program.cs, but as you evolve in your learning journey, you will need to learn more about it so you can handle more complex scenarios. Then we have a weather forecast model, which represents the data that we are passing around inside our application. In this case, it represents the weather forecast with a set of properties that are its characteristics. So now let's run the app and see what happens. And we are redirected to the Swagger interface. Swagger is a very useful tool to document, design, and test, and it's fully supported by .NET, and it comes embedded in the basic scaffolding. The interface is very intuitive. Here we have our get endpoint for the weather forecast and a try it out button. So let's click on that and then click on execute. And we have a response from the API. In this case, a list of objects with information about the weather. And the good thing is that every time we create a new endpoint, it's going to be automatically mapped by Swagger and ready for testing. We don't need to do anything else. Before we start writing code, we have some cleaning up to do. So let's start working in the controller. We're going to change the name of this controller from weather forecast to coffee controller. And let's get rid of this list of weather adjectives. And in the constructor, let's change the name to coffee controller. And let's get rid of the logger as well. We're not going to be using it in this app. Then let's completely remove the existing endpoint, and the controller is ready. In the Program.cs file, let's remove the use authorization method since we're not going to use it. And let's also get rid of the weather forecast model. Now it's time to create our database. So here we have DB browser for SQLite. There is a link in the description below to download this application. It's used to manage your SQLite databases. So let's click on New Database, and the location will be the same root folder of our Coffee API. You can choose whatever name you want. And once the database is created, let's click on Execute SQL and have a look at the code to create our table. Here we have a very straightforward SQL script. We want to create a table with certain properties, and based on the business model that I imagined, some of these properties will be allowed to be null and some won't. We also have a primary key that will increment itself, so every time we insert a new record, we don't need to insert the ID. Then we'll press play to run the query, and don't forget to go to File and Write Changes so that your changes are actually saved. Once that's done, we can see that the file was created in the root folder of the app. And if we go back to the DB browser, we can examine the database structure and browse the table to look at the data. Then let's insert some data manually by clicking on the spreadsheet and the plus sign. And then for each column, let's add a new value. And let's add a second record. Just remember that the properties that I chose for my coffee journal don't need to be the same that you choose. If you think some of these properties are irrelevant or you want to add different ones, it's totally up to you. Then let's go to our app settings.json and register the name of this database as a connection string so that we can call it when we create our repository. I'm recording my voice over a pre-recorded video, and I just realized that I have a strange character after C in my coffee.db in the connection string. I will correct it later in the video, but just make sure that the name in the connection string is the same as in your file. The next step is to create a model. This model will be a class that represents the record table in the database. And for that, let's create a new folder called Modals. And in this folder, let's create a new class called Coffee Record. Now I'll paste the properties for this model, and the properties correspond to the columns I have in my table. And all these properties are fairly straightforward, except for the single price. So I'm using single here because it's the only C# data type that I found that supports the real type in SQLite. If I try decimal or double, it didn't retrieve the price property, so I'm using single, which stores floating point numbers. So now let's create a folder for the repositories. So let's call it repositories, and in this folder, let's create the coffee repository. In the repository pattern, we create a layer between the controller and the database so that we keep our controllers pure, and that makes our code more organized, clean, and maintainable with a nice separation of concerns. It's common practice to implement the repository pattern with dependency injection, which is a technique where we get services working together, where we can inject services into other classes. And it's also common practice to use interfaces for the repository pattern and dependency injection, which makes our life easier later on when we want to test our code. So here we have the coffee repository, which implements the iCoffee repository interface. We are creating our first method, which is the get method, which returns a list of coffee records. So first, I registered this method in the interface, and the compiler will complain if I haven't implemented that method in the repository. So if I click on the red icon that provides solutions for any compiler complaints, I can click on implement interface, and it creates the methods that are missing for us. So here the get method was created. But before we write code in this method, we need to bring in the iConfiguration interface, which we're going to use to grab data from the appsettings.json, which holds our connection string. So we are using dependency injection to bring in the configuration class. And in the get method, we're going to use the connection string in the code to communicate with the database. So let's examine this code. Here we are creating an instance of the SQLite connection class and passing the connection string that we got from the appsettings.json. And this is wrapped in an using statement, since we need to manage this resource. In C#, we need to explicitly end resources that are not managed, which means that they don't close themselves, such as connections, readers, or commands. And when we use the using statement, we don't need to explicitly close it. The connection is closed for us. Then we need to bring in a using statement for the IDB connection, and we need to install a couple of NuGet packages for the SQLite connection and Dapper, which is the mapper that we're using for this project. Let's open Tools and NuGet Package Manager to bring these packages in. So we need Microsoft.data.sqlite and Dapper. And once the packages are installed, we can add the using statements for both. The SQL query is really simple. It's just a select all from records. And then we call the query method from Dapper, declaring we want the coffee record type and passing the query as a parameter. Then we return all the transactions that we just created, and we need to explicitly say that it's a list, since Dapper returns an IEnumerable and not a list. Before we proceed, let's change the name of the file that contains the controller. I forgot to do it earlier, so from weatherforecastcontroller.cs, you'll be a coffeecontroller.cs. Then in the controller, let's inject the coffee repository using dependency injection. So we are plugging our repository into our constructor. So now we are free to use it in our class. Then let's create our first endpoint, and that's going to be the get method, which returns a list of coffee records. We're doing a very simple call to the repository, and after the repository returns that list, we are ordering it descending by date. And before we test it, we need to register our repositories in the Program.cs class. And we do that by calling the addScope method and declaring the interface and the implementation. Then when I first run the app, I run into an error because of the error in my connection string, which we have discussed before. But once we fix our connection string, we are ready to test the API. So if we press play, the Swagger interface comes up and we can test our get method. But when we run the test, we run into an error. And the error says that the date string in the database isn't recognized. So let's go fix that now. After some research, I found out that the date string needs to have the full year and not just 2 digits. So if we fix that, save our changes, and run the API again, we get the correct data returned. The next step is to create a method that will return just one record. So first I registered it in the interface, and then I'm implementing this method in the repository. And the code is very similar to the get method. The difference is that we are passing the ID parameter, so we can grab just one record, and we are returning a record instead of a list. And here is where we can see the magic of Dapper in the query single, which means that we are returning just a single record. We are passing an object with the property that we want to use as a parameter, in this case the ID. So notice that I have this where ID equals @ID. The name of this property needs to be the exact same as the name that I'm passing in my object so that Dapper can map it correctly. Once that's done, we can implement the same method in the controller. So we're returning the getById from the repository. And if we run the API again and go to Swagger, we can test the getById method by passing one of the existing IDs. So let's pass the first one, and we get a response from the API with the record that I requested. So the next step is to add records to our coffee database. So first, let's declare the add method in the interface, and that's going to be void since it doesn't return anything. And I'm changing the order to keep the code organized, following the same order as the interface. And in the method, we have a script that is still very simple. It's just more verbose since we have to declare each property that we want to manipulate. But Dapper makes our life easy again since it groups all of these properties in the record type that's being passed as an argument. And all we need to do is pass that object as an argument in the execute query, and all its properties will be mapped. Back in the controller, I'm going to create an insert method to add the records, and I accidentally called it category because I copied it from another project. And notice that this method has a slightly different format. Here I'm returning an action result, which is a .NET solution that provides different types of responses that are commonly used in APIs. And we're also using a try-catch block. A try-catch is used to handle errors, and it's very easy to understand. All we are doing is trying to run a piece of code, and if we catch errors, we can handle them and prevent the application from crashing. Here, I'm trying to run the repository add method, and I'm returning OK either if I catch an error or if I don't. And I did that because OK in this situation means that there is a response from the API. However, when there is an error, I'm declaring that the success property of this response will be false, And if there are no errors, success will be true. And I'm doing that because when I consume this information in my Angular application, I'm going to have different behaviors depending on the success of the response. So let's run the API again and try to insert a record. So here, if we go to the post, try and insert some data for our record, we're going to get a response from the API. So here I'm adding some mock data, and Swagger provides a very helpful template for our model. And if I execute, in this situation, success is true, which means that our record was added. And we can quickly double check by using Swagger to call the get method, and we can see that our new record is there. The next step is to create a delete method. So let's start by registering it in the interface and then implementing it in the repository. The code is even more simple this time. We are deleting from the table using the ID, and we're creating a new object with that ID to pass as an argument to the execute method. Then we need to go back to the controller and implement that method, and we're going to use the same pattern that we used before with a try and catch block and returning success true if it's a successful operation and success false if there's an error. So if we run the API again, Swagger has detected the delete method, and if we use the 3ID, we get success true. And let's try to retrieve the records to see if it was deleted, and the record with the ID 3 isn't there anymore. And that's it for our API for the moment. For some reason, when I was recording this video, I forgot to create the update method, and I jumped straight into the Angular app. So we're going to return later and create that method when we need it in our front-end application. Okay, it's time to start working on our front-end application. Here I'm using Visual Studio Code, and I'm going to create a new Angular project in the same parent folder of the Coffee API. So not inside the Coffee API folder, but in the parent folder. And that's because I want both projects to be in the same level in my GitHub repository. So the command to create a new project is ng-new and the name of the project, which will be coffee.client. And I'm choosing CSS for my styling and waiting for the project to be scaffolded. Once that's done, you can navigate into the new folder and run ng-serve, which will run the project. And if everything goes well, you're going to see the basic Angular page with the Angular app is running message. So now let's work on getting the list of records from the API and presenting it in our front end. So for that, we need to create a service. A service in Angular is a piece of code that will be shared across many areas of your app. And in this case, the objective of this service is to connect to the API. So the command to create a new service is ng-generate service and the name of the service. And if we have a look at the generated code, we can see that this class is marked as injectable, which is pretty self-explanatory. It means that this class will be available for dependency injection. So the first couple of steps in this service will be to create a property that will hold the API's address, which in this case is localhost and the port, and also to inject the HTTP client class, which will handle the HTTP requests to the API. And always remember to bring in the import statements for the classes that you're using. The next step is very simple. Let's create a getRecords method, which will return the result of calling the get method of the HTTP client, passing the root URL and the name of our controller. And that's all we need for now in the service. The next step is to generate a new component. A component in Angular is the basic building block of the UI, and it's always associated with a template. To create a new component, let's do ng generate component and the name of the component, which will be coffee list, where we will show a list of our records. And if we don't include any extra information, our new component will be created in the app folder, which by default is the root folder of our Angular app. So let's go to our app component.html and delete all of the content. And let's show our recently generated component by using its tag, which is app coffee list. When we run ng-serve, most of our changes will be automatically picked up. So we don't need to run the project every time we make a change. So now we can navigate to our page and we can see that the newly created component works. The next step is to call the service from our component. So for that, let's create a getAllRecords method, and that method we'll call the injected service. To inject the service, all we need to do is pass it as an argument to our constructor, so it's less verbose than in C#. Here we are using the subscribe method, which is used to communicate with observable types. The getRecords method in the coffee service returns an observable, which are very powerful types which allow other classes to observe its changes. And that is a feature that makes our lives as developers way easier, since it can be used to handle asynchronous code, such as when we're trying to communicate with a database and update a page without refreshing it. If you come from an MVC background or JavaScript background, you know how cumbersome it can be to write AJAX calls to handle these scenarios. Now here you can see that we get some data back from the subscription. And since we know the shape of this data, the shape is of the record type, we're going to translate this data into a record type also here in our Angular app. So I've created a folder called Modals, and in it, let's create a file that will contain our type, which will be called record. And the properties will be the same as our type in the API, with only a couple of adjustments, the most important being that we are using a string for our date. And that's okay because I don't need to do any operations with the date in the Angular app. So back to my component, I declare a property called records as an array of the record type. And as we said before, once we subscribe to the getRecords method, we assign the incoming object to the declared property. For consistency, I'm just going to change the name of this file to record.ts instead of coffee.ts, and the same for the name of the interface. And don't forget to add an import for the record. So let's add a console.log to see the incoming data. Make sure the API is also running. And if we go back to our client and open DevTools, let's have a look at the console tab, and we get an error. This error is mentioning injection, so it's an injection error. And that's because we didn't register the HTTP client module that we're using in the service. And we have to do that in the module. Modules in Angular are classes where we register our services, dependencies, components, directives, all the building blocks for our Angular app. So the app is going to reload, and if we go back to the DevTools, we can see a different error, and that's a course error. This happens because of a security feature of browsers called same origin policy, which is used to fight a cyber attack where a malicious website tries to take advantage of our cookies storage system. So basically the browser checks if the origins of the server and the web app match each other. And it does that by checking a combination of the protocol, the host, and the port. In our case, both our applications have the same protocol, which is HTTP, the same host, which is localhost, but the ports are different. So let's fix that by allowing an exception in our API. So fixing it is very simple. What we need to do is call the addCourse method in the Program.cs class, explicitly informing the origins that we allow. This needs to be the same URL that your Angular application is running on. And add the app.useCourse method. It has to be in the same order as in this video. With that, If we run the API again and go back to our local host, we can see that the data is coming through correctly. We can see the objects in our console tab. And that's a very important step because it means that the API can communicate with the front end. So now that the data is coming through, all we need to do is to present it. I'm going to paste some code, and it seems like it's a lot, but it's not really. It's just a table. So here I created a HTML table. This table has a table head and a table row with a bunch of th cells, but the most important part is inside the tBody or the table body tag. In the tBody tag, I have an ng4 directive, which I'm using to loop through the records object, the array of records that I have in my component. So what I'm doing is, for each record, I'm generating a bunch of code, and that code represents a row with all the properties of that record. For each record, in the end of the row, I also have two buttons. One will be used to handle the delete, and the other to edit the record. I'm displaying the properties of my record inside a double curly bracket, which is how the compiler interprets that this is data coming from the component. Notice in the date created and in the price properties, we have a currency and date keywords in yellow. This means that they are pipes. Pipes are a very important feature of Angular. They are directives that we can use to manipulate the incoming data, especially to change the way we want to present it in the front end. And Angular comes with inbuilt pipes that handle common scenarios such as date and currency. And of course, all of this code is available in my GitHub repository for this project. If we go back to the application, we can see that the data is coming through, it's being presented, and the date and the currency are nicely formatted. Now, you probably noticed that we have a bunch of classes in our HTML template, and these are Bootstrap classes that are going to be used to style our project automatically. But at the moment, they're not being used, and that's because we didn't install Bootstrap in our project yet. So let's do that by running the npm install bootstrap in our command line. Then we need to go to our angular.json file, which holds configuration and information about the bundle that will be generated for our application. And we need to insert these two lines of code regarding styling. So we need to add to the styles and to the scripts. And with that, Bootstrap will be included in our bundle, which means that we are going to be using the library. Now, these changes will only take place if you restart the app. So you need to run ng-serve again. And as you can see, Bootstrap is now installed and the application looks way better. But before we continue, let's just install another sub-library by Bootstrap, and that's the icons library, so that we can show the icons in our buttons. So once we do that, we also need to declare it in the angular.json and restart the app. And once we run the app again, we can see that now we have nice icons in our buttons. Now we need to include the ability to insert records into our database. For that, let's create an add record method in the Coffee service and make a very simple call to the post method, passing the URL, the name of the controller, and the record object. Then we need to create another component, and that's where our form will live. The component will be called Coffee Form, and I'm going to add its template to the app component so that we are showing it in the same page as the list. If we do that and run the app, let's see what happens. And here we can see that the coffee form is being rendered on top of the list. Now let's go to the component's TypeScript file so we can create the plumbing for this form. In Angular, there are basically two types of forms, the template-driven forms and the reactive forms. And we're going to be using the reactive. which is the most powerful and versatile way and most widely used in the industry. So let's see how it works. First, we need to declare a property that will be of the type form group. That's a very powerful object that will hold the value and the state of a group of form controls. So here our form group will be called addRecordForm. The next step is to inject the form builder to our constructor. Form builder will help us create our form by creating the abstractControl class, which is the base class for everything that has to do with our form. Then I'm creating a method called emptyForm, which is where we are using the form builder to generate our controls. So here I'm saying that the addRecordForm that I previously created equals a group of controls. And these controls are the record properties that I want to insert. And notice that for each control, I can set a few properties. The first one here will be the initial value of the control, which will be empty for each property and 0 for the ID. And the second one is an array of validators. So I'm setting validators required to the inputs that can't be null, and an extra validator for the coffee shots that can't be negative. So that's a very interesting feature. It makes it very easy to handle validation. Now my compiler is still complaining about my addRecordForm property. It's saying that it hasn't been initialized. And I'm going to fix that by changing the configuration of the app. In the tsconfig file, I need to add the strict property initialization as false. So now I'm going to paste some code into our components HTML. So let's take a closer look at this code. In the form tag, I'm declaring that this is a form group attached to my addRecordForm. And notice that the form group is inside square brackets. Square brackets in Angular mean that the right side of the expression will be interpreted as dynamic. And of course, we want our form group to be dynamic since we will be changing all the time when we're using it. And then we have the ng-submit, which is a directive that specifies a function to run when the form is submitted. And ng-submit is inside parentheses, which in Angular we use to bind events. So we are binding this event to the onSubmit method that we're going to create in the components TypeScript file. After that, we have a bunch of tags for each input. Here we have a few Bootstrap classes, such as form floating in the div and form control in the input. And you should be familiar with everything else that's inside that input and label, since they are just HTML properties. But the one that we are concerned about is the form control name, and it needs to be the same name of the property. That's how the backend will recognize that input. Then underneath the input, we have a p tag, which is being rendered conditionally. And that happens because we're using the *if directive. And here we are saying that if the register form control with the key type, and register form control is a method that we're going to create, is touched, and if that input has errors, we're going to show the validation error message. So once you understand that first input, I have to repeat the same pattern for all other inputs. And in the bottom of this form, we have a button, and the button's name will be defined in the components TypeScript file. We are soon going to create a property for that. But before doing that, let's go to the app module and declare the reactive form module in our imports array. And that will fix most compiler errors. Now, to make the validation work in this form, I'll create a getter method that returns the controls. Getter methods are methods that will access the properties of an object. And in this case, it will be the addRecordForm object. And this method will return an abstract control for each input. So if we go back to the form and have a look at the validation code, we can see that it uses the key, which is the name of the input. And in this situation, we are seeing if it's touched, which means we clicked on that form, and if it has errors. It's important to use the touched property, otherwise it will show the validation errors whenever the input is empty and not just when we try to actually use the input. And last but not least, let's add the property that contains the text of the button. And I'm doing this because this property will be dynamic. The text in the button will be different depending if I'm adding a record or updating a record. So now that our template doesn't have any more errors, we can see that we have a decently looking form, which we now need to test. But at this stage, if you open the DevTools and open the console tab, you can see that there's an error. And this error means that our form is not being recognized at the moment. And that's because even though I created the empty form method, which will register the form, I never called it. So any method will be useless if not called. Once I fix that, the errors go away. The next step to make this form work is to connect it to the service. So I'm bringing in the service into the constructor, and this service will be used inside the onSubmit method, which will obviously handle the submission of the form. We're going to subscribe to the addRecord method, which returns an observable. And for now, all we're going to do is to print the result and reset the form by calling the empty form method. With that, we should be able to insert a new record. So let's try that. So when I submit the form, you can see in the DevTools that the API returned success true. And if we refresh the page, we can see the new record in our list. Of course, later we are going to update this list automatically without having to refresh the page. The next step is to delete records. And that's going to be relatively simple. I've created a method called delete record, and I'm making a very simple call to the delete method of the HTTP client and passing the record's ID. And we're going to handle it in the list component where the button resides. So we have a button on each record in the list. In the component, I'm creating a method called onDelete, and I'm calling the method that I created in the service. I'm also creating a property called deleteID that will be used to target the desired ID to delete. And back on the template, let's add the handler for the button. That's going to be onDelete, passing the record ID. And in the component, we are declaring what the method expects, which is an ID, and that's a number. Then we're going to subscribe to the delete record. And when it gets called, we're going to print the data and get all records, which means that the list will be updated. And let's pass the ID as a parameter and not the delete ID. We're going to use that later. So if we test the app again with the DevTools open, let's click on the delete button, and success true is printed and the record disappears from the list. Now it's time to update the records. This time, let's start with the template. So let's create a handler for the edit button, and that's going to be an onUpdate method which passes the record ID. To update the record, we need to populate the form with the data from that record, which poses a problem. The form and the list live in different components, so how are you going to pass that data between components? Of course, Angular has a solution for that, and it's not very hard. So let's see how it works. Back in the coffee list component.ts, let's create a method called onUpdate, which is going to receive a number as a parameter. This method will call a method in the service called populateForm, and that's what we're going to create now. In the service, let's create a method that will call the next method of a subject. This subject is a property that we're going to declare called populateFormSubject. A subject is one of the most powerful types in Angular. Actually, not Angular, but RxJS, which is one of the most commonly used libraries in Angular. And it's a type that's not only an observable, but it can also be an observer. And that makes it a very versatile solution for communication between components. So we are calling the next method, which will send messages to an observable. And then it will be sent to all the observers of that observable, all the subscribers. For that, we need to create another method that will send this observable, which is the sendPopulateForm. This method will return the observable from the populateForm subject. So now let's go back to the component so we can use this observable. So in the component, let's create a subscription, which is the populateForm subscription. And this subscription will be assigned in the constructor, which means we are activating the subscription every time we activate the component. So we are saying that our subscription property is the result of calling the observable that we created in the service. And we're passing the data from that observable into a populate form method that we are going to create in our component. And that will be the record ID that we initially passed from the list. So let's declare that method. And the code in this method will be very similar to the empty form method, which means that we are basically recreating the form, but this time, instead of initializing the controls with empty values, we are initializing it with the values coming from the record object. And that object is going to come from the getRecord method in the coffee service, which we're going to create. So for each property of that incoming object, we're going to assign a control of the new form. So in the service, let's create that method. And it's a simple method where we call the API's get method, passing the ID. And the reason why we don't need to specify the name of the method is because of the method's signature. In the API, we have two get methods, but they have different signatures since one has a parameter and the other doesn't. If we had more get methods with the same signature, then we would need to configure the API to route by name and not just signature. So back in the component, we're going to call that method, and with the incoming data, which is a record, we're going to populate the form. Now, to grab the data as a record type, we're going to declare a property of the record type, and in the subscribe method, we're going to assign the created property to the incoming data. So this .record equals record, which is the incoming data, and you could name that anything you want, doesn't need to be record, as record, which is a type. So let's declare that property, and don't forget to add the import statement. So now our populate form method is complete, but let's make one more change. Let's change the text of the button depending on if we are adding a record or updating the record. In the empty form, every time it's called, we're going to change the submit button to add record. And when we call the populate form, the submit button will be update record. And that should be enough to populate the form. Let's try to test it now. So if we go back to the form and click on the edit button, let's see what happens. And the form is successfully updated, and the text of the button has changed to update record. And this flow can be a little bit confusing. So here's a diagram explaining what's going on. The list sends the ID to the service, and the service sends the ID to the component, which calls the service and populates the form. Now we need to change the handler for the submission of the form so that it calls the update record in case we're updating and the add record in case we're adding. And that's very simple. When we add a new record, the ID is 0. So that means that if the ID is 0, we're going to call the add record. When we update a record, we are using the existing ID, which is different than 0. If that's the case, we're going to call the update record. So let's create the update record in the service. And again, it's super easy. We're calling the put method in the API, passing the object that we want to update. But obviously, we can't test this function since we forgot to create the update method in the API. So let's do that now. So let's go to the repository in the API and let's create a method that will update the record. First, we add the method to the interface and then to the repository class and send the update query to the database passing the record object. It's a very straightforward update query. And in the controller, we're going to add an update record method, also returning success, false, or true. So if we run the API and try to update a record, let's see what happens. First, I populate the form. I'm changing a couple of the inputs, and it's successfully updated. But at the moment, our list doesn't get updated automatically, even though the database is updated. And the same happens when the insert method gets called. we're adding a new record, but nothing happens in the list. So we need to inform the list component that the database was updated. And we need to tell it to call the getAllRecords method every time it happens. So we're going to use the same technique that we used before to communicate between components. In the service, let's create an update list subject, and then two methods, one that will send a message to an observable and one that will create that observable. We're going to call it sendUpdateList. Once that's done, we can go back to the component and subscribe to that observable. And for that, we're declaring an update list subscription, which is then activated in the constructor. And as a result of that subscription, I'm calling the getAllRecords. So to close that circuit, I need to go to the form component and add the call to the update list in the service in the onSubmit method, which handles the submission of the form. So every time I submit the form, either adding or updating a record, I will update the list. And that should do the job. So let's go back to our application and try to first update a record. And now the list is automatically updated. And then let's try to add a new record. And the new record is already in the list. So we've completed the CRUD operations for our app, but we can definitely improve the user's experience by informing the user about the result of these operations. So let's see how we're going to do that using the power of Angular. In the form template, let's bring in some code that will generate a modal. Here we have a few Bootstrap classes, and we also have a couple of properties that we still need to create. Those will be display pop-up, which we will define when the pop-up is being displayed, and the result pop-up message, which will depend on the success of the operation. We also have a button. All it does is to close the pop-up. And we also have a div for a logo that we will add in the end in the styling section. So back in the component TS, let's add a method that will open the pop-up, and we'll pass a boolean that will represent the success of the operation. And we're going to print different messages depending on the result. And notice that I have a property here called operation, and that's so that we can use the same message for adding a new record or updating a record, just changing the name of the operation. And we will also have a close pop-up method, which will obviously close the pop-up. So now let's add the properties that we need to handle this. The first one will be display pop-up, which is initially none, and a property for the result message, which will be blank. And the operation string will also be blank initially, and we are showing or hiding the form by changing the display property. It's a CSS property that we are changing dynamically, and if it's block, the pop-up is going to show, and if it's none, it doesn't show. And we're also going to create a new type, and that's going to be API response, which will represent the object coming from the API with the result of the operation. So here in my component, I'm declaring a new property, which will be of the type API response. And in our models folder, let's create a new file where the new model will live. And this model will have just one property, the success boolean. Back to the component, we can bring in a using statement for the API response. And then in the subscribe method for our operations, we can define the response as an API response type. Then we can pass the result of that boolean into the open pop-up method and print the message based on this boolean. And we are also changing the operation string depending if it's an update operation or an add operation. And let's do the same for the add record subscription. And that should be enough. Let's go ahead and test our form. First, let's try to update one of our records, and we get the message in the modal. And then let's try to add a new record. and we get the successful message. Now let's add a button to improve the user experience in the delete function. So we're creating a method called openConfirmationPopup, passing the ID that we want to delete. And that ID will be stored in a deleteID property. And we're going to change a displayConfirmationPopup property to block instead of none. So let's add a few properties here. We have the displayConfirmationPopup, the displayResultPopup, and the result pop-up message. Back in the template, let's create the openConfirmationPopup method, passing the ID. And then we will need to change the onDelete method, since it's not being directly called by the button on the list. So onDelete won't receive any arguments anymore. And when we call the delete record on the service, it's going to use the deleteID property that's being stored in the back end. And once we receive a response from the onDelete method, we close the pop-up by calling the closePopup method. So let's create the method just underneath the onDelete. This method will be used to close two pop-ups. We're going to have a dialog to ask if we are sure that we want to delete a record, and then another one similar to the one we have on the form, displaying the result of the operation. So let's start with the confirmation pop-up in the template. So I'm pasting some code, and it's very similar to the code that we have in the form pop-up with a few specific CSS classes. And we have two buttons, one to close the pop-up and the other to actually delete the record. And we also have a space for the logo that we're going to add later. So just to make it clear, once we click on the delete button in the list, it opens the confirmation pop-up and changes the deleteID property in the backend. And once we click on the delete button in the pop-up, it calls the onDelete method, which calls the service, which finally deletes the record in the database. So let's test the whole thing. Let's try to delete a record. It asks for the confirmation, and then if we delete, the record gets deleted and the list gets updated. And now we need to create a pop-up for the result message, similar to what we have when we add a record or update a record. So let's go back to our template and add another modal, very similar to the one that we have in the form, with a space for the logo. And here I have decided to create two different methods to handle the pop-ups. So I'm going to have a close confirmation pop-up method, which will handle just that specific pop-up. And I created another method to open the result pop-up once we delete a record. And I'll also need the API response type to handle my response depending on the result. In this method, I'll print the result depending on the incoming success response. And obviously we can't forget to change the name of that method in the cancel button in the modal to close result pop-up instead of confirmation. So let's create that method in the TS file. Very simple method which changes the CSS property to display the modal. Back on the template, let's change the handler method for the close button in the first modal to close confirmation pop-up. And with all that refactoring, confirmation modal works. And if we press delete, the result modal also works. However, it seems like the cancel button isn't working, so let's see what's going on in the component. And that's because I didn't change the name of the property accordingly. I need to change display result pop-up property. So to test this, let's make a slight change in the API. We're going to make it throw an error by changing the name of the table in the delete query. And once we restart the API and try to delete a record, we can see that there was an error, and that's because we changed the query in the repository. Now let's enhance the style of our application. The first thing we're going to do is insert some HTML and Bootstrap classes so that we split the screen horizontally in big screens. So as you can see, now the form is displaying on the left and it should still work. So let's test everything to see if we didn't break anything. And it still works. And now let's add some CSS to improve the style of the application. I'm not a front-end developer and this is not a CSS tutorial, so I'm just going to paste the code. And even though I added a lot of CSS classes, it's not advanced at all. It's just straightforward CSS with a few media queries for responsivity. What does matter to us is where we put our CSS. If you put it in the styles.css file, that's going to be a global style. For the styles that are not global, you want to put the CSS in the component where it's being applied. So here are my global styles. Then let's add some styles to the app component, which is the root of our application. And here this CSS is handling the background. And notice that I have a link to a picture, but I still don't have this picture on my assets folder. So I'm pasting all the pictures from this project into the assets folder. And once we reload the app, we should be able to see our background. It still doesn't look good because we have more styling to do, but the background works. The next step is to add styling to the list. So here again, I'm pasting some code. And if we go back to the app, it already looks way better. And another important thing with style is to use a palette. Here I'm using a palette based on the picture. So I'm posting a link in the details below where you can get the color codes of a picture, and then using one of those color codes, you can create a palette in another website. And I'm also posting a link for that. Then let's add the styling for the form. And now it looks way nicer. The colors are pretty coherent and everything works. And if we decrease the size of the screen, we can see that the form is stacked on top of the table and all the responsive style works as well. We're getting close to the end, but there are still a few things that we can do to improve the app functionality and style. Just to add an extra touch, I'm adding some pictures to the modals. So let's start with the form component. I'm pasting the code for a picture. And the parameters of this image tag are dynamic, which means that I can change it in the backend. And with that, I'm going to have different pictures depending on the result of the operation. And I'm also adding another div with a logo on top of the form. So back in the TS file, let's add the variables that relate to the picture. The first being the path to the image, and the last two being the dimensions of the image. Then let's go to the open pop-up method and change the path of the image depending on the result of the operation as we discussed. So now we have an error picture when there's an error. Going back to the app, the logo is there. It doesn't look as good in medium screens, but let's see if the modal works. First, let's try to add a new record. And the picture shows successfully. And if we try to update a record, the same is true. Now let's add the logos to the delete modals. So here, if we remember, we have two logos, so let's add it to both. And in the back end, we need to add the properties that will handle those images. And these are delete confirmation image and delete result image. And it's time to test it. As you can see, the confirmation image works and the result image works as well. Then let's test the modal in a small screen. Let's quickly add a new record. And it works. If we try to update it, it also works. And if we try to delete it, everything works. Another important styling concern in this app is the ability to scroll the list independently of the form, which is a very useful tool since most of our tables will exceed the size of the screen. But something that I didn't deal with was pagination. So in case we have a million records, we're going to have to find a solution so that we don't bring all of that data from the database every time we show the table, but I'm leaving that for a more advanced tutorial. Now let's talk a little bit about validation. At the moment, the users of the form don't know which inputs are required. If you remember, we've already added validation to the form and it should work, but the users will only find out after making a mistake. So here I'm adding an asterisk to each required input and a message in the end saying that asterisk means required input or required field. And if we go back to the form, the changes are there and it's a little bit better user experience. It's very important to pay attention to these types of details. Before wrapping up, there's one more thing we need to do, and it regards error handling. At the moment, we're getting a response from the API, which can be success true or false, depending on the result of the operation, and we're showing a message accordingly. But what happens if the API isn't working? In that case, there is no response, which means that the user won't even know that there is an error. So let's add a simple solution for that. Let's add a property called hasAPI_responded, which is a boolean initially set to false. And we're going to set it to true in case we get any response from the API. And that happens inside the subscription. If we submit the form and this property remains false, we open the pop-up with an error message. So if I turn the API off and try to submit a valid form, I get an error message. Notice that I wrap the logic inside the onSubmit method in a block that will only run if the addRecord form is valid. If that's not the case, we have return, which means that nothing will happen, but the validation messages will still show to the user. The last thing we need to do is to unsubscribe from our observables. It's good practice in Angular to dispose of our observables since they are unmanaged resources, and that prevents memory leaks. And we're going to use the ng-on-destroy hook to handle this operation. Angular has methods called lifecycle hooks, which are methods where we can run code in different stages of a component's life. Previously, we have seen the ng-on-init, which is where we can run code when the component gets started. So in the coffee form, we're going to unsubscribe from the populate form subscription and the coffee service subscription. And every time we use a lifecycle hook, we need to implement its interface. So we can see that this component implements on init, and we need to implement on destroy as well. So let's go ahead and do the same in the coffee list component. Let's dispose of our subscriptions. And that's the final step. We are done. Thank you everyone for watching. Feel free to ask questions in the comments below or via our Discord community. And don't forget to subscribe to the channel. We're going to have at least a new project every month. And you can also give us suggestions for projects that you want to see covered here. See you next time.